Hi, welcome to my video on the definition of second derivative. This is the first video in the unit on second derivative of polynomial functions. Second derivative. Definition of second derivative. One way to say it is the rate of change of a point on a graph. Or we could say it's the slope of the slope. Most people say it's the derivative of a function. So this is the first derivative. Now we're going to do the second derivative. Derivative notation. The first derivative is defined as f prime x, or it could be y prime, or it could be dy dx. The second derivative, in using the function notation f of x, is f double prime x. Or if you're going to go y prime, second derivative is y double prime, 2 primes. Or if you're going to use dy dx, it's d squared y dx squared. And let me explain that right here. So if you take dy dx, if you take dy dx and you do the derivative, you can do d of dx. So there's dy dx, the first derivative. Now we're going to do d of dx on the first one. So notice the d times d is d squared y. And we got an x dx dx, so it's dx being squared. We don't put a bracket around that, or they haven't in calculus. So the second derivative is d squared y dy dx. So that's the second derivative. And to illustrate the second derivative, let's use f of x equals x squared. So the first derivative is f of x prime. So it's 2 goes in front, 2 times 1 is 2, and the exponent decreases by 1. So the second derivative on that is the same as if you're, so we got a 2x, so the derivative of 2x is just 2, because that's a linear. If we're using y equals x squared, then the first derivative is y prime, so it's 2x, and the second derivative on the first one is 2. So the two of these are the same, only I'm just doing different notation. And if we have y equals x squared again, and we use d dx on the y, and that's d dx on x squared. So we have dy dx right here, and the derivative of x squared in terms of x is just 2x. So I'm just explaining. This is one you have to get used to here. And the second derivative on that is d dx on dy dx. So that's d dx on the 2x. So d times d is d squared y, and dx times dx is dx being squared, and the derivative of 2x in terms of x is just 2. So this is the one you have to get used to. So this is function notation f of x. This is just in terms of y. Y first derivative y prime, and y to double prime is the second derivative. Okay, let's do some more examples of that. Find the second derivative of each. Well, I got f of x, so the first derivative is f prime. So negative 3 times 2 is negative 6x. And the derivative of a linear is just the slope, 4. Derivative of a constant is 0. So now we got the first derivative done. Now we'll do the derivative of that derivative, which is the second derivative. So negative 6x derivative is negative 6, because that's a linear. Derivative of constants is 0. Now we have y. There's a cubic, so the first derivative is y prime, so that's a 3 x squared negative 12x plus 7. Derivative of a constant is 0. And the derivative, that's the first derivative, is y prime. Y double prime is the derivative of this one. So that's 3 times 2 is 6x. And derivative of a linear is just a negative 12. Derivative of a constant is 0. And we have another one to do. Find the second derivative of this one. Or I should say, if y equals negative 3/4 x to the fourth plus 2x cubed minus 3x squared minus 8x plus 2, find d squared x and dx squared. So that's the same as find the double derivative. So we do d dx on the y. So we do d dx on this function. Now I'm writing it all down, but we can take a shortcut. We don't have to, I'm just explaining it. So instead of doing all that, I can go from here to here and go, that's dy dx. I didn't have to do all this, but I'm just showing it to you. So the derivative of this quart x degree 4 is dx is 4 times negative 3/4 is negative 3x cubed. 2 times 3 is 6. The cube becomes a square. Negative 2 times 2 is negative 6, and the 2 becomes a 1. And the derivative of a negative 8x is negative 8. That's a linear. So this degree drops from 1 down to a 0, and x to the 0 is 1. Derivative of a constant is 0. Now, we'll go d squared y, or dx squared. So the derivative on this, so I'm doing d dx off this side and d dx here. So instead of putting d dx down on each side, I'll just go d squared y and dx squared. So the derivative here is negative 6x. Oh, that's made a mistake. See, that's a 3 there. 4 going to a 3. And the 3 goes to a 2. So a cubic, quart x degree 4 goes to a cubic goes to a quadratic. Cubic goes to a quadratic, which goes to a linear. 6 times 2 is 12x. And the linear goes to a constant, which is negative 6. And the constant, derivative of a constant is 0. So that's some examples of doing the second derivative. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content that I have on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.